Welcome to this video where we'll be exploring one of the fundamental concepts in computer science and mathematics, the floating point exponent. This topic may seem complex at first, but it's essential to understand how computers represent numbers, especially when working with fractional or decimal values. In this video, we'll break down the concept of floating point exponents, explaining what they are, how they work, and their significance in computing. By the end of this video, you'll have a solid understanding of the floating point exponent and its role in computer arithmetic. Whether you're a student programmer or simply curious about how computers work, this explanation is designed to be accessible and informative for everyone. So let's start with the basics. In computing, numbers are represented using binary code, a series of zeros and ones that the computer can understand. However, when we deal with decimal or fractional numbers, things get a bit more complicated. That's where floating point representation comes in. A floating point is a way to represent real numbers in computers, allowing for both integer and fractional parts to be stored and manipulated. The format typically consists of three main components: the sign bit, the exponent, and the mantissa, or significand. The exponent is crucial here, as it indicates the power of 2, by which the mantissa should be multiplied to get the actual value represented by the floating point number. Essentially, it tells us where to place the decimal point in our number. Think of it like scientific notation, where you have a base number, the mantissa, and an exponent that tells you how many places to shift the decimal point. For example, the number 1234 can be represented as 1.234 tens teen. Here, 1.234 is similar to our mantissa, and 10.3 acts like our exponent. However, in computers, instead of using base 10 for exponents, we use base 2, because binary is the native language of computers. This means that the exponent will tell us how many places to shift the binary point, the equivalent of a decimal point in binary, rather than a decimal point. To summarize, the key points about floating point exponents are: they are part of the floating point representation format used by computers. The exponent tells the computer where to place the binary point in a number, allowing for efficient storage and manipulation of fractional numbers. Unlike scientific notation, which uses base 10, floating point exponents use base 2 because they work with binary code. Understanding these points gives you a solid foundation on how computers handle real numbers and can help you appreciate the complexity and elegance of computer arithmetic. That's it for this video about floating point exponents. I hope you now have a clearer understanding of this fundamental concept in computing. If you found this explanation helpful, please like this video and consider subscribing to stay updated with more informative content. In the comments below, let me know if you have any questions or topics related to computer science that you'd like explored further. Your engagement helps shape future videos, so thank you for watching and participating.